So what are we going to talk about? Data-driven applications for analyst productivity. How can we improve the productivity of analysts within organizations so that they can use their data much more effectively and learn from their colleagues without actually bothering them? So a typical analyst workflow, in that particular workflow, what are the barriers to productivity? So we will try to argue that search and exploration of data are equally important as query execution efficiency. If you see, most of the technology out there is actually focused more on the query execution and storage and less on search and exploration. And then we'll ask the question, how could technology help people be much more productive using their data? Then we'll end up with a demo concretizing the ideas that we discussed. So let's start with an example question, not very atypical in most enterprises. Find top 50 US West Coast customers, right? If I'm an analyst and I'm faced with this particular question, I'd like to see if anyone else in the organization has actually answered this question. If so, I can build or use a particular query or analysis, and I have bootstrapped myself much farther down the analyst workflow, and I could benefit from improving my own productivity. Right? If I didn't find a question or a query that someone else has written for this particular question, can I find the relevant data? What are the tables that I need to use? Understand them before I actually build the query. So that's where the exploration part comes in. So taking a table, what are the semantics of the data in the table? What do the columns mean? Which particular columns should I aggregate? What are the filters that I need to put in so that I get the right set of rows from that table? What are the related tables that I need to join with, and so on? This is all the exploration phase that goes on before the query building even starts, right? So abstracting this workflow starts off with asking a question, followed by a search. If I'm lucky, I'm going to find a relevant query that a colleague of mine or someone else in the organization has written. I can either modify it or run it and get to my answer. If I don't find a similar query, I have to go find the relevant data sets, explore them to understand the semantics, plan the query, and then actually write it before I run it. Now, this may iterate a few times, depending on how complex the query is and how complex the question is and how easy the data is to understand. Actually, that's the last part, which is fairly important. Now, we would argue that if an analyst is not able to find other people's queries, that's actually hurting the productivity of the analyst as well as the entire organization. In most cases, a question such as top 50 US West Coast customers is such a common question that you would expect to find other people asking the question and answering it repeatedly, right? Maybe not top 50 US West Coast customers, maybe it's top 100 Australian customers, something very similar, but that can actually bootstrap other analysts learning from each other and getting to improving their own productivity. So let me drill down into a few of these steps. Search, what do we mean by that? So going back to top 50 US West Coast customers, suppose I assume it's by profit, ordered by profit. I'll start with a search as customer profit, and I would expect results coming back. And the results could be of multiple types, could be relevant tables that contain customer data or profit data. Columns could be computed because I'm asking for profit, and that may not be a single column, it actually may be a derived column or a computed column. Articles. So if you look at an organization, they may have certain rules saying how do you compute customer profit, and this may be written in a particular glossary article and surfacing it to the analyst just in time when they're actually looking for customer profit is what is important. Oops, I clicked a couple of times. And notice that these tables and queries could actually be distributed across databases. One of the other things that search technology has to bridge in this particular case, especially in the data domain, is that the terms that I use for searching these artifacts, the data objects or queries, customer profit, may be very different from the way the tables are named. The tables could be PRFT or some other abbreviation or some other artifact which is sort of tribal knowledge, but a user may not know that particular keyword that's used for naming the tables, right? Now, let's go on to the next step. If I find a particular table that is relevant for me, let's say customers table, there are a whole bunch of columns, cust NM, ID, PRFT, net income, STDT, STDate, so on and so forth. Now, I need to understand what these columns mean. Some of them are obvious: custom name, perhaps customer name, customer ID, profit, net income, and so on. But what is the difference between profit and net income? Should I use net income? Should I use profit? Oh, well, tough luck. You have to go find an analyst who has used this table prior and get an answer to that question, right? Subsequently, can I trust the values in these columns? How is this table populated? How often is it refreshed? Is it fresh? If I want the most recent data, does this table have that data in there or not? All of these are questions. As an analyst, you have to go through these set of questions before you actually get down to building a query even. Subsequently, I want the customer addresses based in West Coast, so I need to join this table with the address table. Where is that address table? How do I join it? Should I use a left outer join? Should I use an inner join? These are all the semantic questions that go into the exploration phase. Think of this whole process as actually you're planning the query as you're planning writing a program. Well, we have a lot more focus and design built into writing a program, but not for a particular query, right? All of this understanding and semantics have to be codified into building the query. Specific tables, filters, joins, what is the computation column, and so on. And often these queries tend to be fairly complex, and it may involve either nested queries or intermediate tables that need to be materialized and used in the subsequent set of queries, right? And of course, one of the most important consideration is efficiency. How efficient is this query that I am building? Now, most of the database optimizers out there will take a query and execute it, optimize it such that it can be executed most efficiently for that particular data set, but for that particular query. They are not going to change the semantics of the query, and that is the contract. It's all good, well specified API. But in our particular scenario, I am an analyst, I am building this query. Now, I have the actual ability to add constraints to this query, such as this filter. If you look at these two queries, the one on the left and the one on the right, the only difference is that particular where clause, which is stipulating that only consider the most recent transactions so that I get the top 50 customers based on those transactions. Now, that seems to be a meaningful constraint. As an analyst, I may have forgotten or I may have skipped that particular constraint, and if someone else, an expert, looks at the query, they would say, oh yeah, put in this constraint, because then you will have much faster execution because you have fewer rows to process, and of course, more relevant results because you are only considering the recent data, right? And this is the difference between a database query optimization and a semantic query optimization, which is what is exactly relevant for helping an analyst achieve much more productivity in their particular workflow. And of course, this will also hopefully make the query execution itself less prone to inefficiencies and DBAs yelling at analysts saying, oh, you wrote an inefficient query, now you're in the dock and you're not allowed to write queries for 2 more days. So, we have seen that happen in certain cases. So, summarizing all the questions before even an analyst can get to building a query. Which table contains the sales information? Where do I find the sales transactions? Who knows about this if I have more questions? Where did this table come from? What do I join this table to with address table? How do I filter? So on, all the semantic questions. When I say West Coast, should I include Hawaii or not? All of these are related to data semantics, right? Now, analysts typically are faced with a trade-off. Should I be quick, ignore some of the answers, some of these questions and assume whatever I'm doing is correct, or should I try to be correct and actually figure out answers to all of these questions? Ideally, we want them to be both quick and correct. And we are not the first ones to recognize this problem. And this is a common theme across many of the analyst domains. And there's been a quote from KM World saying 90% of the time that knowledge workers spend in creating new reports is actually recreating information that already exists, right? And helping them find other people's queries, explore data faster is one way of making analyst teams much more productive, making much more effective of their data environments. So going back to this analyst workflow, most of the current technology is focused here, making sure that queries run efficiently and scalably. It's all good. The technology has gotten so much better than what it was maybe 10 years ago, maybe 15 years ago, that we are collecting massive amounts of data. The tables are getting deeper in terms of the number of rows. The number of tables within databases is getting wider and wider. Certain customers of ours have millions of tables, but this places a burden in the exploration and analysis. Analysts, on the other hand, now have to deal with all this data complexity, and the barrier to analysis is actually increasing significantly. So how do we help eliminate this barrier? So answer to ourselves a bunch of what if questions. What if searching for relevant data within the organization is as easy as Googling? So today, whenever we want some information on the web, we would go out, Google, figure out the relevant web pages, make decisions, and move on. This has become a habit. But within the enterprise, if I want to find, oh, has anyone else done this report on top 50 US West Coast customers, it's not so easy. We're all out of luck. We would like to make that as easy as Googling. Further, if you find a particular query or a piece of data that you want to use, how do I understand the semantics? Who do I approach? Who has used this before? What are the other queries that have run on this? All of these are exploratory questions. No technological help on this front. And imagine a scenario where you're actually building a query and you would get recommendations from experts pushed just in time. This is as though an expert is looking over your shoulder and helping you write queries. What if that were a possibility, right? So for the rest of the talk, we'll focus on the third aspect. If you want to talk about the first two things, we'll be happy to talk offline on those two topics. So going back to the questions before queries, so there are a whole bunch of questions on what tables are important, which tables contain sales information, and so on. But the recommendations engine would be able to answer this subset of questions which are not grayed out. How do I query the transactions tables? What do I join on? These are all the questions when I'm actually building the query, a query recommendation system should help. Let me start with an example, going back to our finding top 50 US West Coast customers by profit. Suppose I've been able to, with search and exploration, I've been able to whittle down to joining this customers table with transactions table and added certain predicates like this. But now I need to figure out what the profit formula is and what the join condition is. What if you had a suggestion coming in from this intelligent query editor saying, oh, you may be interested in using sum of net income, sum of profit, sum of revenue minus CAQ, use one of these candidates. Now, how do I decide which particular candidate is useful? Well, you need to understand the context behind each of these suggestions, saying, oh yeah, if you take the computed column sum of profit, this has actually been endorsed by a steward, Jason Steward, and the logical name of that particular column is tax adjusted profit, and of course it has been used 123 times in the last 3 months or 6 months, and most recently by John Doe in finance. and if I happen to be in that team, and I trust John Doe, I can go ahead and select that suggestion and move on with building the query. Notice that all of this happens in the query editor, and I did not need to switch my context between email, IM, phone, or a wiki page. All of those are detractors and impact productivity. This is one way of improving productivity for query authoring significantly. So philosophically, where does this kind of a query recommendation engine sit? So if you look at the common recommendation paradigms out there, there's a Google Auto Suggest, and Auto Suggest within all our IDEs such as Eclipse or Sublime, whichever is your favorite editor. And if you look at the Google Auto Suggest, it's actually based on queries from across the web, across all the users that are using Google. But the context itself is fairly narrow. It's based only on the 2 or 3 keywords that are in that query bar. On the other hand, with IDEs, all the suggestions that IDEs typically make are only based on my personal context within that file or within that particular project. But the context itself is long ranging, because I may get a suggestion based on a function that I have defined in a different file in the project or in the same file. We are somewhere in between. We want the suggestions coming from users across the enterprise, and the context itself, because SQL queries can tend to be complex and hundreds of lines in most practical cases, we want the context to be fairly large as well in terms of suggestions. So abstracting this query snippets recommendation, imagine that was my cursor. I filled out this rest of this query, and the recommendation should depend on what my current context is. The context could be SQL keywords, select and from. I'm in the select context, which means my recommendation should be more either columns or computed columns and not tables and other kinds of recommendations. It also should depend on what the data context is. Which are the data objects I'm actually trying to query? Customers, transactions, customer, NM column, and so on. So my recommendation should be based on that particular context. So the derived columns or the computed or the suggestion should come from the semantic context, which is the data tables or the data objects that I have already mentioned in the query, and the cursor context. Where is my cursor? What are the reserved keywords around the cursor? What are the tables or the data objects around the cursor? All of this is fairly relevant in making the recommendations happen. So in terms of technical challenges, as you saw, these queries are partial. They're not completely formed. You need recommendations coming up based on these partially formed queries, and of course quality of recommendations is very important, and they have to improve as more of the query is built. And another important criteria for a successful query editor, already people use their own favorite query editors or command line tools and so on, so the benefit has to be seen from day one. That's an important criterion. In terms of efficiency, my typing should not be impeded. So I should match, the recommendation engine should match the speed of typing, and the experience should be fairly smooth from that angle as well. So jumping into the recommendation quality, what are the ingredients to actually make a successful recommendation engine? A whole bunch of ingredients that need to go. Of course, the cursor. Where is my cursor? What are the surrounding keywords? Usage, diversity of usage, and so on. I'll drill down into a few of these examples just to give you the context before jumping back up into a different issue. Oops. So if you take the customers table again, you need to understand where all has it been used. And the usage can come from a variety of contexts, whether it is queries that other people have written or I myself have written, search, how many people have actually searched for this table, how many people have browsed to this particular table in the database. So all of this falls under the usage paradigm. If we get metrics and statistics from this kind of usage, we can make our recommendation engine fairly accurate. Similarly, diversity of usage. Is it important that one particular user or one particular application is actually querying this customers table thousands of times, versus is it better if more people and through the organization are using it? or people in the finance teams using it, or people in the marketing teams using this particular table. Product managers, are they using this particular table? So diverse usage is actually fairly relevant in many cases, especially if my team is different from any of these three teams. Co-occurrence. In many cases, as we are building out the query, we are trying to look for what are the computed columns, what are the other tables that I can join with, and co-occurrence is an important measure there. Has the customer's table been joined with C address a lot of times? And if so, that becomes a relevant candidate. Similarly, a computed column such as profit, if it happens to be co-occurring with in queries with customer's table, whenever the customer's table has been mentioned, that's an important criterion. Join, so on and so forth. So object used together often tend to be used together again. So that is the hypothesis. We use this to improve the recommendation quality. Cursor context. If I'm in this particular context, the best suggestions happen to be cust ID, profit, and sum of net income, and so on. And if I typed a particular character, then my recommendation should change, and the previous recommendation should be filtered effectively by the context, additional context that I have provided to the recommendation engine. So a bunch of other ingredients that are very important. Recency. How recently has this table been used? How recently has this computed column been used? Personalization. How often have I used this table or surrounding tables or related tables? That should determine the recommendation accuracy as well. Errors, that's interesting. As we type quickly, we tend to make certain errors in characters, these keystrokes. How do we recover from, how does the recommendation engine recover from such keystroke errors and make the recommendation quality robust to those kinds of errors? Access. Not everyone has access to all the tables in the database. So the recommendation engine has to realize that access role permissions and figure out where I fit in that world and give me only suggestions that are relevant for me, right? So those are effectively filters. Access is a filter. Cursor is, context is a filter. Which keystrokes have I already typed? And this is not again a one-time process. It has to improve as more and more data is collected. So we track all user actions, the type, the keystrokes, the mouse behavior, where all is the user focusing on. Has the user been clicking on the context at the bottom that we provide in the query editor? All of these are relevant to figure out recommendation quality and improve that over time. There are a whole bunch of other challenges. How do we deploy this recommendation engine? Should we dynamically compute this recommendation engine based on all the statistics that we have, or should we pre-materialize an index? Because we have to match the speed of typing, it makes sense to pre-materialize an index. Now, where should that index stay? Should it be on the server or should it be on the client side to deal with network latencies and burstiness? And in terms of user experience, should it be a browser app? Should it be a desktop app? Browser app has certain advantages, but it comes with limitations on the browser compatibility, cache limits, and so on. Desktop app has its own challenges in terms of deploying it with Windows, Mac, various versions, and so on. All of these considerations had to be put in place before we come up with one specific solution or a couple of solutions that are targeted to analysts in their particular environments. So in summary, we have considered the analyst workflow. We stressed on the exploration and search for data as equally important as query execution. Stressing on just the query execution efficiency and the ability to increase the compute engine's capacity to deal with massive amounts of data is all nice and fine, but the analyst, the complexity of data analysis in such massive data environments is also increasing, and we need to recognize that and stress on that particular technology as well. And we illustrated a couple of technologies that could benefit from human enhancements to already a machine learning system such as the recommendation system that can be built to reduce this barrier. So with this, I'll hand over to GT to do a quick demo of the query recommendation system and concretize some of the ideas that we have talked about.
So So as Venki gets us up, I can start giving you a little bit of background on the demo. So he showed you exactly what the problem is. He showed you what our approach to solving that problem is, but I'm going to walk you through the actual practical steps that a user would follow to start using a tool that addresses these issues. And just for the purpose of the demo, this is switching out again. For the purpose of the demo, imagine I'm a new analyst. I've been tasked with creating a report that looks at the number of customer communications we've had in a certain region and for every one of our products. And I'm not very familiar with the new data source I'm working on. I've just been tasked with it recently. I do not know what the physical structure of the data is. I know what my business problem is. I know what the business question I want to ask is, but I do not know in the actual data's terms, in the physical names, what I want to look at. So with Lation, I can start typing out my query. So I'm going to start typing out my select query. It's going to start suggesting different objects that I might want to look at. So in this case, I want to look at complaints. And again, it's going to give me an idea of what I might want to work with. So I can actually decide on the fly if any one of these is the actual thing I'd like to look at. So I'm going to, in this case, I want to search for product ID. I'm going to see it's an endorsed object. And if I give you a little bit more space here, I also get some more information on what kind of data type it is, where it's coming from, and as I continue to type out, it's going to still narrow down and give me even better options for the objects I might want to select. So last, I'm going to count the number of complaints that were coming in, and I'm going to be ready to make a choice for which table I might actually want to use.
Yeah, command minus.
There we go. So you can actually see a little bit better. So I'm going to get a sample of the data I'm working with so I can actually see what I'm working on, decide if this is the best fit for my analysis. I'm going to be able to scroll through the different options. I can see, for example, this one has been endorsed by a user. I can make sure that this might actually answer my question. If I hadn't been able to see that, here's another option, very similar. It's also called customer complaints. So this could have been the table for my analysis. But I can see it's been deprecated by somebody. So another person has shared their knowledge about the quality of that data. And I can use that information to make a better decision and choose this one for my analysis. So when it comes to actually joining this table to another one to extend my analysis, Elation is again going to help me understand, based on the prior usage within the organization, which tables do you typically join to the customer complaints table I'm working on? So I can see what my options are. Again, make a decision based on actual context that has been provided and developed over time by the whole organization. So I don't have to necessarily go and find somebody that has worked on this in the past to get their perspective on it. And when it comes to actually joining these two tables, Relation's also going to know what are the different ways you could possibly join these tables. So I have two options. The first one has been deprecated, and it's also been executed about 20 times. The second one is endorsed and has been executed 130 times. And I happen to know those users. I know they're great with this data, so I can make the decision to go ahead and use this one based on that information. It's also going to generally speed up the process of writing this query, because I can, again, let's say I want to look at the Northeast region where I'm based. I'll be able to make, again, a choice between different options. I don't have to manually define every filter I'm going to use, because I can see which others have been used in the past by my organization. They've been titled, so I can leverage that. And what it does is it avoids situations like this one, where someone has fortunately deprecated this filter, but a user manually typed out all the variables within this definition of Northeast, but he forgot to include Rhode Island. So he could have gone on writing his query for a long time, constantly using the wrong definition. So again, I'm going to choose the right one. And let's say I want to specifically look at credit card products. So again, I can search for credit cards. In the data, that's actually stored as a numeric value, in this case a 7. And I did not know that. I knew I wanted a credit card. I didn't know I wanted the data for number 7 in the product ID. But Elation is able to point me to the right data object to answer my question in this specific instance. So that is really how I went from not knowing much about this data to making a series of decisions as to which data objects I'd like to include that actually made sense and improved as I went along with my query by providing the best objects and the best suggestions for what I'd written up until that point. With elation, this information, this knowledge is also supposed to be used to seed others' analysis. So I can save this, and that's going to make it instantly available. I can add some metadata to that. So complaints in the Northeast, I can save that. So it makes it easier for users to even understand what my analysis represents. And we have a concept of saving versus publishing, which again helps users understand and gives them context about this analysis. So even if I've saved it, that could be a useful analysis to them. When I publish it, what that really means is that I'm endorsing it as a more complete, comprehensive work piece of analysis. So you could leverage it as is or make a change. But if I haven't, I've saved it, there might still be pieces of information in there that are useful to you. But you do need to know whether it is meant for final use or if it's just a work in progress. So again, it's giving you the necessary context to make the best decision for your analytical work. So that kind of covers the demo and kind of took Venki's theory and actually showed you how we do it. So I'm going to pass it back.
Yep, I think at this point we are done. We can start with, if you have any questions that are left unanswered, we can take those. Yep, yes, Bob. Thank you.